Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study what is the moment of a force and what are the laws of movements and its applications. More applications in this session. In the previous session, we also covered what are the law of movements and also applications, some of the few applications. Let us begin here. What are the few more applications are? Sir, here the most important thing is that this law of movements will come into the picture when parallel forces are acting on your body, or for a system of coplanar parallel forces. And there are two types of parallel forces. One is like parallel, another one is unlike parallel forces. Like parallel forces means when the forces are acting on your beam, when the forces are acting on a simply supported beam, the forces which are acting, these are all downwards. If we consider these forces, all forces are in the same direction, then the system of forces which are acting in the same plane, then these type of forces are known as coplanar parallel forces system. Coplanar parallel forces system. But coplanar, whatever, like or unlike, coplanar like parallel forces system. And if we consider the total forces, the system, if we consider the total system of forces, some of the forces which are acting downwards and some of the forces, the reaction forces, are acting upwards. So this type of forces system is known as, again, coplanar unlike parallel force system. Unlike parallel force system. So that means here we understood what is a coplanar like parallel, coplanar unlike parallel force system. So coplanar like parallel force system, all forces are acting in the same direction. It can be either upward or downward direction. Whereas coplanar unlike parallel force system, some of the forces acts downwards and some of the forces acts upwards. So when here mostly we consider the system of forces, the coplanar system of forces comes into the picture when the coplanar unlike parallel forces system, where under these conditions how to find out the resultant force. So how to find out the resultant force? By using the law of moments. So here the two parallel, what is the characteristics? Parallel forces system. Some of the characteristics of the parallel force system is that the forces acts are parallel to each other. The point of intersection may not be there at one. No two forces intersect at same point. So there should not be no intersection. Having these points are contact points. Intersecting points are individual. Here, if we consider the intersection points of all these forces, these are at various points, point 1, point 2, point 3, point 4. And here this point and this point. There are 6 forces are acting and 6 various points. But no two forces intersect at the same point. That is the meaning here. And one more thing. The line of actions are parallel to each other. Okay, the line of actions are parallel to each other. That's why those are known as here, these type of forces, these are the parallel forces. That's why here it is coplanar parallel force system. Okay. One more thing is that we want to find out the resultant force of such force system. We will use the principle of moments. What is the principle of moments or law of moments? Law of moments is nothing but the algebraic sum of all moments about any arbitrary point equal to 0. If we consider any point about that arbitrary point, the law of moments, there is sigma m equal to 0. Mathematically, moment is different from momentum. Okay, the moment is different from momentum. Okay, don't get confusion. The moment is here Moment mathematically, m equal to force into perpendicular distance. This m equal to fd, f times d. D is the perpendicular distance. What is the perpendicular distance? The distance is the distance between the line of action of the force to the point where it is acting. That is m equal to f times d. That's what we have discussed. That is the introduction. Now here, what is the direction of the moment of the forces? The direction of the moment of force, there are two types of moments. One is clockwise movement, another one is counterclockwise movement. The effect of this moment, what is the effect of this moment is, this movement causes or gives rotary motion to the body. Alright, gives rotary motion to the body. Alright, so what will happen? This rotary motion can be two types. One is clockwise, another one is anti-clockwise or counterclockwise direction. If the motion, the force is acting on your body in such a way that, or the moment is, the force is acting on your body such a way that it gives counterclockwise movement, then it is known as the clockwise movement, or clockwise motion, then it is known as the clockwise movement. If the force is acting in a particular direction on a particular point such a way that the body is rotating in a counterclockwise direction, then it is known as the counterclockwise movement. So in these figures, there are two figures, just to give you a revision before connecting, to understand the connection, what we have studied in previous session and what you are going to study. Further, just recapitulating what is the concepts of the moments. Here, the figure 2 indicates F is acting at a particular here. F is the direction of, this is the F is acting, force, the point O. And the F is moving such a way that the F is acting on your body such a way that the body moves in which direction? From my screen, it is in a particular direction. That particular direction movement, here it is known as the, from our screen, if you understand, it is the counterclockwise, it is the clockwise direction from my side. But from after, no, it can become a counterclockwise also if it acts in different direction. But the point movement is that the movement is here O, and F is acting in this direction. Alright. The F is acting in the direction. What will happen? That based on the motion of the body will give that motion movement called known as the perpendicular direction is the perpendicular distance, line of action F. And what is the movement here? Movement M equal to F times R, where R is the distance between the line of action of the force to the point. But what type of distance here it is? The distance here it is a perpendicular distance. Alright, that is the perpendicular distance. Now if you consider figure 1, the direction of the moment axis is upwards. Alright, but the direction of the moment, you can see from top view, is the counterclockwise direction, is the counterclockwise movement, and here it is a clockwise movement. Now, as we have studied already, moment of the force and here, and there are different types. And what are the applications? The application of this moment of force is affects the turning effect. Actually, moment is the name for the turning effect that force exert on objects. A moment is the name for the turning effect that forces exert on the objects. Okay. Now, if the door is pushing, if you push the door, if you are applying, if you want to open the door or closing the door, if you are opening the door, you have to apply the force on the door will give rotation. Why? It is pivoted at another point, another end. So this door opens. Why it is rotating? If you see the top view, the rotary motion of the door you can see. It is hinged at one end. It is rotating. Yes. Okay. That means the movement helps to open the doors or closing the doors. And the application of the moment of a force is also known as, one more thing is that if you want to screwing the bottle screws, you have to apply the force, moment of the force. That moment causes to open the cap of a bottle. And one more thing is that, let us go for one more, some of the applications here mentioned. The turning effect of the force refers to what? This turning effect is nothing but what? Rotational analogous of a force is known as the torque. And this torque helps us to open and close the door. and also torque helps us open and closing the bottle caps and also turn your wrench. If you want to tighten the wrench or closing the nuts, this this turning effect, this torque is highly useful. All right. Next, there are some more examples. Vehicle engines apply torque and rotate the axle. This torque will be developed near the engine shaft. The shaft helps to rotate the axle. That axle helps to rotate the rear wheels to rotate, move. It is connected to the wheels of the vehicles. And one more thing, this torque also helps the pencil. Rotate a pencil inside a sharpener. Rotating a pencil inside a sharpener. And also torque also highly required to rotate the steering wheel during the driving of a four-wheeler. If you consider the four-wheeler, the rotation gives, this the torque helps. So this rotary force is applied manually, okay, by our hands. And also torque is needed to rotate, open the doorknob. The torque is needed to open the doorknob so as to open the door. And also children apply the torque while riding seesaws in parks. What is the seesaws in riding? Seesaws in parks. Yeah, this is the seesaw. One child will sit, A child here and B child here. What they will do? They will push down, another child will rise up. But please understand here, this is the fulcrum point, this is the pivot point. They will sit in equal distances. Okay, equal distances, D1 and D2, both are D1. So if they are not equal in distance, what will happen? So there is again the concept of moment effects, M equal to F times D. This M at the constant force, F equal to M by D. If D increases, what about F? Decreases. If D increases, the applied force will be reduced. If D decreases, what happens? The distance between, the point between the line of action, perpendicular distance. If D increases, F becomes reduced. If D decreases, then F should be increased. What is the meaning here? The meaning is that, this is the meaning here. The pushing force. Before you make it here, the door you want to open, if you push the door here, less force is required to open the door. Whereas, because why? The D is larger, D is more distance. The perpendicular distance is smaller. Then what will happen? F equal to M by D. Then this distance, what will happen? Reduce. When distance is low, larger pushing force is required to push more force. Why? How can we know? How can we understand the physics behind this principle? Based on this equation, F equal to M by D. F equal to M by D. Alright? In this manner, we can understand where we have to apply the force, such a way that, where we apply, such a way that the location, point of location of the applied force is highly important in order to easily open the door with less effort, with less force. Otherwise, no matter, the moment when D becomes 0, very important concept. Here, from this equation, when D becomes 0, if D is 0, what will happen? F need requires, what is the how much force? That is M by 0. Infinity force, F becomes infinity. You have to apply infinite force. That means what? Door won't be opened, MD becomes 0. Another meaning is that the direction, the point of location of applied force is same as the pivot point, the hinged point. That hinged point is so tougher, D becomes 0. What will happen? You need the force infinite. It won't be opened. Such a way that, what do we? The D should be maintained. The distance should be maintained such a way that the force will be, F will be minimized. That's why while opening the door, you will not push the door at this point or at this point. You will push the door at the end of the point, such a way that you need less force to open. Alright. So, this is based on what? How can we know it? Based on the concept of the movement. Now, as we have studied the seesaw examples, very important is that, so much is the very beautiful, the analogy we can understand here. the A body is having A and B. This A is having maybe less weight. WA is less than WB. But the distance, if A is locating at this distance, A, the B will be lifted easily. Why? Because, the B can't be. Why? Because here you need to push down, more force is required. Alright, even though some of the children, they will locate different, even though unequal weights also, but they can lift the person very easily. How it is? If B is sitting here, the fulcrum point distances are same. Okay, if the A is a little bit such a way that if A is sitting at this point, the B, even though weight of the B is more than weight of A, but still the distance is more, with less force, you can lift the more weight. So this is the concept of simple machine. Okay, what is the simple machine concept? Simple machine concept is that you can lift heavy machine, heavy rock. The body is more, you can apply less force. Less force, you can lift heavy weight. Why? The distance between, the distance is the fulcrum distance. This perpendicular distance is what? Perpendicular distance is more when that is F equal to M by D. When distance is high, F is required low and we can lift heavy weight. That is the concept of what? Simple machine concept. The simple machine concept here, one more thing is that the heavy lift, the heavy weight can be lifted with the help of chain drives. When the heavy lift, if you go to automobile industries at a small scale, any industries of automobile shops or working places, they lift heavy engine with the help of what? With the help of the sprocket, and they will connect here. The chain sprocket here, they will pull here. So that if you pull like that, this engine will be lifted easily. This is the concept of simple machines. Now, the point is that children apply a torque here, riding seesaw in parks or places, guarding places. Now, another important example for torque is that if you want to tighten the screws with the help of the spanner, so if you rotate, this is the torque. Okay, that is the momentum principle. You will apply here perpendicular to the direction. This is the spanner. Okay, in the spanner you will apply, you tighten the nut. So the distance F into D, this is the momentum. Moment M equal to F times D. So these are the examples of for the torque or the moment principle. Now here we are going to classify. There are various classifications of a moment based on the application. And here there are three types of moments. One is a turning moment, another one is bending moment, and third one is twisting moment. If you see here, what is the turning moment? The turning moment is helping to rotate or to tighten or loosen the screws or nuts. And the twisting moment, this is the twisting moment concept. The torque will be applied. It develops the shear stresses inside the body. One end is fixed, another one if you rotate, the twisting moment. And the third moment is known as the bending moment. Here, this is the bending moment. The force causes and the distance. This force leads to what? This bending moment is the output of bending moment is what? Deflection. The output of bending moment is deflection of the beam. Okay. Output of bending moment is deflection of the beam. Deflection takes place. And output of the twisting moment is shear stresses will be developed. The torque, shear stresses will be developed. Okay. The twisting moment causes to rotation. This rotation causes to torsion. The torque, twisting moment, shear stresses. And the turning movement, this turning movement leads to what is the output? Tightening. The tightening of the screws. This is also shear stresses will be developed, but it becomes tightening. So the rotation takes place. So all these movements, if you understand, the deflection of the beam is the deflection causing what? Rotation. All these movements, the output of all these movements is rotation. Okay, twisting movement, a turning movement. Okay, all these are giving, these are the things of what? Causing moments. Now here, especially, let me explain more in detail of this turning movement, torque. This is a turning movement. Here the simple example. And in the case of bending movement, how it happens? Here what type of beam here it is? One end of the beam. This is the beam. One end is fixed, another end is free. This type of beam is known as a cantilever beam. Okay, and another type of beam, it is known as a fixed beam. This is the beam. Beam is nothing but a component, or beam is nothing but a concrete structure, or it is fixed both the ends. Then it is known as a fixed beam. Next, as I told you, it is the cantilever beam. Here it is mentioned. One more beam is known as a simply supported beam. It is a simply supported beam. Simply supported beam. Now here is the beam is supported. These are the supports. This support is known as a knife edge support, and here it is known as a hinged support. Here it is a hinged support. Hinged. What about type of support? It's the knife edge support. Now, because of the supports, the reactions will be, if it is hinged support, there will be two reactions, either towards horizontal and vertical directions, towards upward direction, or towards left or right direction. For knife edge support, only one reaction, that is vertical upward direction. So this type of beam is known as simply supported beam. Suppose if simply supported beam is subjected to a force or load. If simply supported beam is subjected to a load, is a force acting, then what type of deflection, how the deflection takes place? The deflection curve becomes in this direction. The deflection curve will be downward direction. This causing what? Yes, rotation again causing, if you make it deflection, bending, this causes deflection. This type of movement is known as the bending movement. This bending movement causes to deflect because of the F force. And what will happen inside the beam? The shear force will be developed, and also because of this bending movement leads to shear forces or shear stresses. The point is that how the force affects, when the force acts on a beam, bending movement. When the force, the twisting movement, when the force affects leads to rotate the body, that is known as twisting movement torque. Similarly, when the force acts along the perpendicular distance, the affects not along the force acts. Force times D, it tightens the screw. It is also rotary motion. So this rotary motion causes turning movement. Another one is twisting movement, and the third one is bending movement. Bending movement, turning movement, and twisting movement. These are the three types of movements. Okay, and now this turning movement we have seen pictorially, but what is the definition? What is the tense to the body? What will affect? This turning movement tends to rotate your body about a fulcrum. Turning movement rotates a body about a fulcrum. In this case, the body is free to rotate about a fulcrum. This is what a turning movement. This is the fulcrum. About your fulcrum, it is giving rotation. Okay. And what about bending movement? This bending movement, tends to bend your body. This bending movement tends to bend your body. about its fixed ends. Bending takes place. Here this is the beam, one end is fixed. If you apply the load, what will happen? It bends. Bending moments bend the body, but about which axis? About a fixed end. About fixed end it will bend. That's what happened here. About a fixed end. This bending moment, bending the body about a fixed end. Turning moment, here the body is rotating about its fulcrum. And the next one is the twisting moment. The twisting moment, what will happen? Twisted a shaft about one of its fixed ends. Again, fixed end only. If you twist hand, if the twisting takes place about its fixed end. Okay. So this twisting is known as causes what? You put about its fixed end, it is moving. Twisting takes place. But it causes to develop what? Shear stresses. Alright. So, now, very important thing is that, so far we have covered what is the twisting movement, turning movement and bending movement. Now, let us how to geometric representation of a moment of a force. In this figure, we can understand is the triangle AOB is the triangle. Here, the moment of a force about a point. We are going to find out the moment of a force about this point O is equal to the moment of a force about the point is equal to what is happening? The moment of a force about the point F into OC. That is equal to the area of the triangle. That means twice the area of the triangle. So, what we are going to do, the moment of a force about this point is twice the triangle. Okay, this is O and F into OC. Is twice the triangle, area of the triangle. What is that? Further, how we are going to find out? We consider a force F acting on your body and is represented by a vector AB and is represented by vector AB. Now let O be the point about which moment is taking place. Moment of the force is to be calculated about the point O. About the point O, we are going to consider the moment of a force. Now, the moment of a force about O equal to, that is M equal to F times OC, F into OC. So, moment of force about O that equal to, what is F is nothing but a vector AB, that is AB times OC. Now, from figure, AB clearly that AB equal to F vector, that's a quantity now. If you multiply by both the numerator, multiply and divided by with 2, that M equal to 2 times 1 by 2 times AB into OC, then 2 times, what is 1 by 2? Half base into height. What is the base? AB is the base and the height is OC. That means this half AB into OC is nothing but area of the triangle. So 2 times area of the triangle is equal to what? 2 times the area of the triangle equal to moment of the force in this case. That means moment is the geometric representation. That's why here it is known as geometric representation of a moment of force. So the moment of the force equal to 2 times area of triangle OAB. Okay. Area of triangle OAB. Area of triangle. That is area of triangle equal to half base into height. That's what we proved here. Next, what is the principle of the moment? The principle of moment is that if your body is in equilibrium, under the action of a force, if the body is in equilibrium under the action of number of forces acting simultaneously on your body, then algebraic sum of all moments or forces of all the forces about your point is equal to 0. That means then it will be in momentary equilibrium. If it is not equal to 0, then it is not in equilibrium. That means it is under rotation. That is the meaning. Sigma m equal to 0. The point is that if a body is in equilibrium under the action of number of forces acting on a body simultaneously, their moments sigma m, algebraic sum of all moments, should be equal to 0. Then only the body will be in equilibrium, means no rotary motion. How? Why it is? What is the algebraic sum meaning? So algebraic sum means the sum of the clockwise and the anti-clockwise movements. So we consider clockwise movements are positive or anti-clockwise movements are negative. If we consider it, then some of the movements acts as a positive values, gives positive values, and some of the counter anti-clockwise movements, though, that gives the negative. This positive and negative should be equal, should be balanced. Otherwise, what will happen? Very simple. If we consider seesaw example, okay, the distance is same. It is also d, and also here also d. In this figure, it may be different distances, f1 and f2. If f1 equal to f2, then the body will be in a horizontal position. If f1 is greater than f2, f1 is high, f2 is low, what will happen? The body moves down. Yes, clockwise motion, it just comes down. Because f1 is more, that's it goes down f1 direction. And f2 will be, what will happen? Lifted up. Even though acting downwards, that end will push up. Or if f1 is less than f2, what will happen? Less than f2, f2 moves down, f1 goes up. So that means if we consider the movement clockwise, this f1 into fd, yeah, as I am considering here, f1 and f2. As I told you, this is the pivot point d, and here also d. The sum of the moments about the point O, this f1 is giving what? In this direction, one counterclockwise, f2 is giving clockwise. So f2 into d about the point O, the counterclockwise is considering positive bending moment, and 9 as f1 into d equal to 0. Then the body is in equilibrium. Then what is happening here? If we understand, f1 equal to f2 happens. So the d is the common, f2 into d equal to f1 into d. D get cancelled. Then f1 equal to f2. So if f1 and f2 both are equal, then what will happen? f1 and f2 are equal. That means it is in equilibrium in this case because the distance is same. So the body is in equilibrium. Point is that this is the clockwise movements positive, anti-clockwise movement is considered as negative. That algebraic sum should be equal to 0. Then the body is in equilibrium. This law or this principle is known as the principle of movement of a force. This principle is known as principle of movements of a force. That is the meaning here. Alright. Now, consider in this figure. We are considering different figures here. In these figures, f1, f2, f3, f4. This f2 having a distance d2. f1 having a distance d1, f3, d3, f4, d4. The moment of a force, f1 is f1 d1. Moment of force, f2 is f2 into d2. Moment of force, f3 is f3 into d3. Moment of force, f4 is f4 into d4. Now consider this point. This f1 d1 is giving which direction? Counterclockwise or anti-clockwise. And f2 d2 also anti-clockwise. This f4 d4 clockwise. f3 d3 which direction? Clockwise direction from my point of view of the screen. Now the sum of all these forces, consider, it depends upon our consideration. If we consider f1 d1 here in this case study, we consider as f1 d1, this counterclockwise direction is positive. So f1 d1 plus f2 d2. Okay, one side direction positive, another opposite direction is negative. f3 d3 and f4 d4. So that sigma m equal to 0. That means F1 d1 plus F2 d2 that equal to F3 d3 plus F4 d4. So that means sigma m equal to 0. That means clockwise movements, sum of anti-clockwise movements equal to sum of clockwise movements. That is also known as the principle of moments of a force. With this we verified the principle of moments of a force. Sigma m equal to 0 we started. Then principle of verification moment of a force we verified here. That is clockwise movements equal to anti-clockwise movements. Then only the body will be in equilibrium. Under what condition? Momentarily equilibrium. Moment, not momentumly. Momentarily equilibrium. That means momentarily equilibrium means it is no rotation motion. It doesn't move. It is in static condition in spite of all forces acts. Parallel forces acts on your body. Alright. So that is moment equilibrium concept. Okay. In this session, we have followed different references textbooks and we studied what is the application of the moment of a force by considering and the principle of moment of a force that is principle of moment of force equal, that is sigma m equal to 0. These are the references we followed. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.